Expressions, or terms as they are called, they are the data structures in Prolog. They look like function calls, but they are not evaluated. They are simply just data. The shown example illustrates that terms can be typed in different ways, although the underlying representation is the same. The equality operator in Prolog refers to equation solving on data structures. It's called unification. Variables in capitals can occur on both sides of the equation. Note that order is important. Contrary to standard mathematics, 1 plus 2 is not equal to 2 plus 1, reminding that terms are not evaluated. Programs in Prolog consist of facts and rules. The shown example defines the father relationship between individuals. Think of databases, where each stated fact is just a row of a table. You can now ask queries, which is also the Prolog command line prompt. Like in ordinary mathematics, there might be multiple solutions for each question asked. We are now going to show how to work with Prolog interactively. At this point, you can use whatever Prolog implementation and your favorite editor. Here I'll be using mine, Emacs, for which I'll write a new source code file called mysource.pl. The PL extension is Prolog's file extension, although it is ambiguous with Perl. In this file, we write the facts that were previously shown. Moving over to the second window, we'll now start the Prolog coin implementation from the terminal shell. Ignore the information that is displayed on startup. Next, we'll load the facts into memory. To do this, we use the bracket notation with the file name without the extension. In Prolog, all sentences are ended with period. Once the facts are loaded into memory, we can now ask the queries. For illustration, we'll use the same queries as previously shown. There are multiple operators in Prolog. They are mostly related to logical operations. For example, comma in Prolog means logical AND, semicolon means logical OR, colon followed by a minus sign means implied by, and backslash followed by an equal sign means not equal. Equipped with these operators, we can do more advanced queries. For example, here's how we can find all grandchildren of Dave. Another example is to find all individuals that are brothers. Sometimes we get duplicate listings. Not syntactically, but from a human perspective that John and Tom are brothers naturally means that Tom and John are also brothers. There are more advanced operators that can be used to avoid these duplicates. We can add new rules to our program to make things easier. See these as subroutines if you're familiar with traditional programming. In the case of figuring out who are brothers, we've added another extra operator, the @ sign less than, which enforces alphabetical order. Using this trick, we can filter out the duplicates. Lists in Prolog are built on top of dotted pairs. Many Prolog implementations allow you to explicitly use dotted pairs to build lists. The list bracket notation is just syntactic sugar for these dotted pairs. Using the bracket vertical bar notation, you can extract the first element and the tail of the remaining elements. It's common in Prolog to use the suffix s for plural. With this vertical bar notation, you can easily add elements to the beginning of a list. But if the list ends with a variable, you can also add elements to the end of a list. We'll now write a predicate member, which is going to be true if the first argument exists in the list of the second argument. Obviously, it is true if the element we are looking for is the first element. Here, underscore means an unnamed variable. Otherwise, the element we're looking for must be in the remaining part of the list. We can now ask queries using member. For sanity, let's make sure it is true and false in some simple examples. At last, Prolog does not define how a predicate will be used. By making the first argument a variable, we'll enumerate all elements of the second argument. We'll now write the predicate append, which is going to be true if the third argument is the concatenation of the lists of the two first arguments. In the case where the first argument is the empty list, then the third argument is just the second argument. Otherwise, imagine that we already appended the remaining list. Then the first element of the first argument must also be the first element of the third argument. To reiterate that Prolog does not define how a predicate will be used, you can see that by letting an arbitrary argument be a variable, it will try to find a solution for it. Now we write the predicate reverse, which is going to be true if the second argument is the reverse of the first. To accomplish that, we can take advantage of a helper predicate and the use of an accumulator. As seen, reversing something is symmetric, so logically it doesn't matter if we ask to reverse the first or the second argument. As a final example, we'll take a brief look at the predicate palindrome, which is true if the argument, a list, is a palindrome. For example, the list 12321 is a palindrome, whereas 123210 is not. Ponder for a brief time on how you would try to solve this. Perhaps some helper predicates, some accumulators, trying to keep track of when you're halfway through the list. What if the list is odd or even in length? It's common to think in this way. That's how you would pursue it in a traditional programming language you're likely familiar with. Sometimes it's stunning to see how easy things are in Prolog. To be curious, you could try to query a palindrome with a variable. You'll observe how it'll enumerate all possible palindromes. It'll never end as there are infinitely many. We've talked about terms as data structures, unification, solving equations on data structures, predicates with facts and rules, some well-known basic predicates in Prolog, and how to implement them. What we haven't talked about is the internal search engine of Prolog, or equation solver. These details are required to understand when writing larger Prolog programs. So where is the blockchain in all of this? Where is the cryptocurrency? These topics will be covered in later episodes, and you'll see how they'll become a perfect fit. Until then, take care and hope to see you next time.